Hello everyone, myself Assistant Professor in Engineering College Ahmedabad. In today's session in VLSI Technology, we discuss about a morphological operator, and also we discuss about the different types of morphological operator and the application of morphological operator and the use of morphological operator, that how with help of the morphological operator we try to improve the quality of image, and also we try to improve the data, and also we try to improve the resolutions point of view in terms of the pixel value using a morphological operator. So we just go ahead with the morphological operator and we discuss in depth. Now the first question arises in our mind, that what is morphological image processing? So to extract the image component that are useful in representations and description of region shapes such as boundary extraction, skeleton, convolution, gain, morphological filtering, thinning, pruning, and also the other type of morphological operator like erosion, dilation. So the main objective of the morphological image processing is that extract the boundary and the description of the image, and it play a main role to extract the meaningful content from the images. So morphological image processing is play a main role to extract the meaningful content after the segmentation and before the segmentation. So it play a main role that I already told you. Now, in previous session we already discussed about the erosion, dilation, opening, closing, and also we discussed about the practical use of erosion, dilation, opening and closing. So now we move ahead and we discuss about different types of morphological operator, like we're talking about heat or mist transformation. Now what exactly the concept of heat or mist transformation? It is simply a concept is that if your data or your pixel value will be matched, then it called as a heat. And if it will not match with the mask component, then it will definitely mist component. So it's called as a heat or mist transformation technique. Now, if the P is denote the set component of D and its background, the match or set to match of B in A, it denote as A star B is equal to A minus D intersection A complementary minus W minus D. So what exactly the meaning of heat or mist transformation is that if your mask value will be matched with your image, then it's called as a heat, and if it is not matched with your mask component, then it's called as a mist component. Now B is equal to B1 and B2, B1 is equal to object and B2 is equal to background. So A star B is equal to A minus B1, which in terms of the object, intersection of A complementary minus B2. So it's called as simple as that a heat or mist transformation technique. Now what exactly heat or mist transformation technique is? The simplest way is that if your mask and if your input image, it will match, or we can say that the background or your object will be matched at the same pixel, it's called as a heat, because both the pixel value became same, so it's called as a heat. And if it is not a match, then it's called as a mist. Okay. So now we go ahead with the second topic, and it's talking about the boundary extraction. Now, what is a boundary extraction? So boundary extraction is nothing but when we are talking about some information, and when we extract some meaningful information from the boundary area, then we are talking about the boundary extraction concept. So the boundary of a set A can be obtained by first encoding A by B and then performing the set of difference between A and its erosion. So when we are talking about the extraction some information from the boundary, at the same time we have to discuss about different types of region, and we have to perform the different types of operating points like A and B. So we have to apply the encoding, and after applying the encoding, that we have to apply the erosion method to extract the meaningful content and region. So it's called as a V of A is equal to A minus B. Ultimately, to extract the boundary condition, to extract the boundary data, we have to apply the V of A is equal to A minus B. It's nothing but to extract the meaningful content from the region. Now, we move on to the next topic, talking about the hole filling. Now, what exactly is the meaning of hole filling? The hole filling is that if you try to improve the quality of image, if you try to extract the meaningful content from the image, if you try to extract some meaningful data. So at the same time, we have to deal with the different types of images. We have to deal with the different types of data. And for that same time, we have to deal with the whole filling concept. So what exactly the concept of whole filling? In terms of the whole filling, it means, or we can say that it replaces a pixel value or the matrix value where the pixel value is empty, means it's filled the empty pixels, and because of that reason you get a better resolution as compared to existing images. Now from an array of x0 of 0, the same size as an array containing A, expect the location in x0 correspond to give point in each oil which is set to 1. It is set to 1 which is filled by the value. So xk is equal to xk minus 1 plus b of a complemented at a stand for 1, 2, 3, 4, 2. If we talking about the 8-bit data, then we have to deal with the 256-bit. If we deal with 16-bit data, then we have to deal with the vice versa. It's around 6.5 bits. So stop the iterations if x of k is equal to x of k minus 1. Definitely, if your matrix will be reached, then you have to stop the iterations. Now the next we are talking about the convex rule. A set A is said to be convex if the straight line segment joining any 2 points in A line entirely within it. The convex rule H or of an arbitrary set S is the smallest convolution set containing S. Let the B of I is equal to I, we have 1, 2, 3, 4 up to 4 that we have. Fine. It represents the 4th structuring element. And procedure is continuously applied like x of k is equal to x of k minus 1 multiplication of B of I and B of k. Where I similarly is 1, 2, 3, 4 up to n and k is equal to 1, 2, 3. So the similar pattern that we have to apply for the convex rule is C of A is equal to union I is equal to 1, 2, 4. It's D I. So this is a similar pattern is going on each and every method and each and every pattern, that how we are getting the meaningful content from the data or from the images. Now we're talking about some other type of morphological operator that play a main role when we're talking about some hand data recognition pattern, or we have to deal with some corner points, or whenever we have to deal with some meaningful data that which is available inside the images. And for the same time, we have to deal with some other type of morphological operator that we see right now. In terms of the thinning, so in terms of the thinning, you are extracting the meaningful content from the internal side. We can say that. So it's a symbol of A cross tuple B is equal to A minus A star B is equal to A union A star B complement. It is a concept of thinning. Fine. In terms of thinning, you are taking the A and B, both the structuring element and the object. You can take both as images and getting the meaningful content. As you can see, the A structuring element B is defined as definition as I already told you. A intersection is B into complement. Now next we're talking about thinking based concept. In terms of the thinking is defined as expression is totally opposite. As you can see, A union A star B. So thinning of A by sequence of structuring this element of B. So A structuring element of B is going on in similar pattern as and C. So it is a main use to background the set and the component extraction method. So it play a main role to extracting the data. The use procedure is going on to removing the background procedure. Remove the background data. Now we move on to the next topic and talking about the skeleton. Now we are already familiar with this word, what exactly skeleton is. See, when we discuss about the skeleton of this concept, ultimately we discuss about main element, or we can say that if you are talking about the skeleton of our body. And as you know, the skeleton of a male and also for the woman is also similar, but the outer portion change. So similarly, when we are talking about skeleton in terms of the image processing, we have to work on the internal part of the image, and we have to represent and we have to extract some meaningful content which represent the whole data. It's called as a skeleton. Fine. So we can say that it's internal portion of the image, or we can say that the actual portion of the image, or we can say that the minimum pixels that huge data or information is called as a skeleton in simple word. So a skeleton as of A of a set A has the following properties, as you can see. If Z is the point of S of A and D is the largest disk centered at Z and containing in A. One cannot find the largest disk containing D of Z in A. So as you can see, there are the two different places that you are getting the meaningful content, and we have to extract the meaningful data from the disk. If you extract the meaningful data from the disk, or if you extract the meaningful content from the disk, then you will definitely getting the meaningful content. Okay, so in terms of the what exactly skeleton is, what exactly the convolution, or we can say that the convex view is, what exactly boundary extraction is, what exactly the other type of morphological operator is work, that we definitely see in the practical applications, and when we apply in terms of the software part like Python in MATLAB, then you are getting the better idea that how we apply this in image processing and how we extract the meaningful content from the image processing. Fine. So in terms of the skeleton, make sure that when we discuss about the skeleton point of view, always you have to remember one thing: when we discuss about the skeleton, ultimately we discuss about only a meaningful content from the images, or we can say that the meaningful part from the images. Okay. So it's a skeleton, and already we learned different types of morphological operator too. So still, if you have any doubt in any morphological operator, or any doubt in repeat or base, or convolution, or convex view, or any doubt in thinning, you can say that thinking this concept, then you can contact me on my email ID. So still, if you have any doubt, then you can tell me. So thank you for watching the video, and still, if you have any doubt, then you can contact me on my email ID. So thank you for watching.